Okay, the position of equilibrium. You'll be able to remember phrases like doing this shifts the equilibrium to the left or to the right. So we've got to get back into that. And the things that affected the position of equilibrium were temperature, pressure, concentration. Now, Le Chatelier's principle essentially says that whatever you do to a system at equilibrium, if you try and impose a change on it, it will resist that change, or it will adjust to try and reduce the effect of that particular change. Okay? So whatever you do to it, it does the opposite back. Makes sense, yeah? So if you increase the concentration of a substance, then the equilibrium will shift in order to try and reduce the concentration of that substance. Let's have a look at this equilibrium. It's a funny little equilibrium sign there. This is ammonia reacting with oxygen to produce nitrogen monoxide and water. Okay, this happens quite a high temperature, and the energy or the enthalpy change for this reaction is minus 950 kilojoules per mole. Okay, so the forward reaction is exothermic. If we increase the concentration of ammonia, which is what we do, or what they do in industry, isn't it? They put the reactants in. If we put more ammonia in and more oxygen, typically you put in more of the thing that's cheaper and more readily available, then this reaction will shift to the right, producing my nitrogen monoxide, which I later use to make nitric acid. Okay. If I take the nitrogen monoxide out, as you can remember from the Haber process, then again the equilibrium will shift to the right. If I added water to this equilibrium, it would shift to the left. Okay? So this typical situation in industry is you keep adding the reactants and you force the equilibrium to the right and you try and somehow remove the products as they're made. You keep the whole thing as a continuous process. If you're talking about gases, obviously, we have to talk about pressure. And pressure really is the concentration of a gas. If you increase the pressure, you increase the number of molecules of the gas, you increase the concentration of the gas. Okay, so pressure is a measure of concentration, isn't it? So Le Chatelier's principle can be applied. For example, this is the Haber process. You know that we run this at how many atmospheres? Yes, 200 atmospheres. So 200 times atmospheric pressure. If we increase the pressure, there are fewer moles on the right or fewer molecules on the right. So there are 4 moles on the left here, 2 moles on the right. So the equilibrium will shift to the right, producing more ammonia. A higher yield of ammonia is achieved with high pressure. This is one of Haber's breakthroughs, doing it at very high pressure. We then have to think about temperature, don't we? This is what, remember, if you to think back to IGCSE and optimum conditions, then we know the forward reaction here is exothermic. But if we increase the temperature, it will shift to the left in the endothermic direction. So ideally, theoretically, we should have a low temperature so it shifts in the exothermic direction to the right. We should. But in reality, we use an optimum temperature, we use a moderate temperature so that the reaction rate is not affected too much, so it doesn't happen too slowly. So let's move on to temperature. We've just mentioned it, haven't we? Essentially, you've got to, initially when you're given any kind of reaction, you check to make sure, you check to ascertain what the energy change for the forward reaction is. And here, in this example, it's exothermic. So increasing temperature would cause it to shift to the left. Decreasing temperature would cause it to shift to the right. If we gave it enough time, it would reach equilibrium, but the reaction rate might be quite slow. Okay. And I think this essentially is saying what we've just said. You probably all feel quite comfortable with this. This is really all IGCSE so far, isn't it? So there's nothing new under the sun, as they say. Okay, there you go. A task for you. Let's have a look at the pages in the textbook and do the questions. And then any problems, we can talk about them on the chat. Good luck.